Good day everyone, I'm your Mr. ATL and welcome back to my channel. So today's video, we're going to discuss about the inverse trigonometric functions. So let us have a recall first about the properties of inverse functions. Number one property, if f is a one-to-one function, then the inverse function f inverse exists. So how is this? I'm going to sketch the graph of the function y equals sine x. And we're going to determine if it is a one-to-one function or not. Okay, so in our previous lesson, in the function y equals to sine x, our amplitude is 1 and the period is 2 pi. So let me draw the horizontal line that will serve as our guide in sketching the graph of the function y equals to sine x. Sine 0 will give us a value of 0. Okay, so when x is pi over 4, we can get that it's square root of 2 over 2, or in decimal it's 0.71. So let us write it in here. Okay, so next, when x is pi over 2, we will get that is 1. Since sine pi over 2 is 1, so the point will be in this point. Okay, so when x is 3 pi over 4, that is sine 3 pi over 4, that is square root of 2 over 2, or 0.71 in decimal. Next, when x is pi, we will get that y equals to sine pi, and sine of pi is 0, so that is pi comma 0. Next, when your x is 5 pi over 4, you will get that it is negative square root of 2 over 2, or the negative 0.71. So it's in here. Next, when your x is 3 pi over 2, you will get that y equals to sine 3 pi over 2, and the value of that is negative 1. So that will be 3 pi over 2 comma negative 1. Okay, when x is 7 pi over 4, that will be y equals to sine 7 pi over 4, and that is negative square root of 2 over 2. So in this part, that's negative. And next, when x is 2 pi, you will get that y equals to sine of 2 pi, which is 0. Okay, so connecting the points using smooth curve, this will be the graph of the y equals to sine x with a period of 2 pi. We can also continue the graph until in this part, and so on. Also, when your x is negative pi over 4, you will get y equals to sine of negative pi over 4, where the value of sine of negative pi over 4 is negative square root of 2 over 2, and that will be negative 0.71, so in this part. Next, when your x is negative pi over 2, you will get y equals to sine of negative pi over 2, in which the value of sine of negative pi over 2 is negative 1. So we have negative pi over 2 comma negative 1. Okay, so we have x is negative 3 pi over 4, that will be y equals to sine of negative 3 pi over 4, and the value of that is negative square root of 2 over 2, which is negative 0.71. Okay, so when x is negative pi, you will get that, and when your x is negative 5 pi over 4, you will get that x is positive square root of 2 over 2, or positive 0.71. Okay, so let us now connect these points using smooth curve. So this is now the graph of the y equals to sine x on this part, and so on. Having now the graph of y equals to sine x, can you now determine if the given function is a one-to-one function or not? Okay, So we can do that by simply looking at the graph. In our previous lesson, when we say one-to-one function, the graph will pass the horizontal line test and the vertical line test. Okay, so let us check if this will pass the vertical and the horizontal line test. If I am going to draw a vertical line there, like this, so the vertical line will intersect the graph at one point. On this part also, it's only 1 point. But if I am going to draw a horizontal line on the graph, like this, so how many points of intersection? We have 1, 2, 3, 4. So therefore, this will not pass the horizontal line test. Therefore, this is not a one-to-one function. But if I'm going to restrict the domain of the given function y equals to sine x from negative pi over 2, until positive pi over 2, okay, so this graph will pass the horizontal line test and the vertical line test. Look at this. So if I will draw a vertical line, this will intersect the graph at 1 point. If I will draw a horizontal line, looking at this graph, this will intersect at exactly 1 point also. So therefore, in the function y is equal to sine x, we're going to restrict its domain from negative pi over 2 until positive pi over 2, or in interval notation, from negative pi over 2 until positive pi over 2. But in the range, that is the same from negative 1 until positive 1. So how will you write it? So we have y is greater or equal to negative 1 but less than or equal to positive 1. In interval notation, that is from negative 1 until positive 1. This is already a one-to-one function. Okay, property number 2. The domain of the inverse function is the range of the original function. Also, the range of the inverse function is the domain of the original function. So how is that? Okay, so I'm going to transfer first the graph of the y equals sine x, where the domain is from negative pi over 2 until pi over 2 only. This is the graph of the function y is equal to sine x, with a restricted domain from negative pi over 2 until pi over 2. So according to our property of the inverse function in number 2, the domain of the inverse function will be the range of the original function. Also, the range of the inverse function will be the domain of the original function. So since the range will become the domain and the domain will become the range, so we are going to interchange the coordinates for that. So let us draw the Cartesian plane once again. Okay, so x coordinate will become your y coordinate and your y coordinate will be your x coordinate. So on this point, we have pi over 2 comma 1. So it will become 1 comma pi over 2. So how is that again? We have 1 and pi over 2. Next is pi over 4 comma square root of 2 over 2, or 0.71. So here it is. Next, 0 and 0, if you will interchange the domain and the range, that will be 0 comma 0 also. And for this one, we have negative 0.71 for the x and negative pi over 4. And the last, we have negative pi over 2 comma negative 1. That will become negative 1 comma negative pi over 2. Okay, so connecting these points using smooth curve, this is now our graph. So this is the graph of the function y equals to inverse of sine x, where the domain is from negative 1 until positive 1. And the range is from negative pi over 2 until pi over 2. That is the number 2 property. So let us go to the third property. Okay, number 3 property of the inverse function. Okay, number 3, the graph of the inverse function is the reflection of the graph of the original function with respect to the line y equals x. Okay, so this is the graph of the function y equals to sine x, where the domain is from negative pi over 2 until pi over 2. And this is the graph of its inverse. Okay, so what have you noticed? So let me draw the line y equals x. Okay, so this is the line equals y equals x. This is the graph of y equals to sine x. And this is the graph of the y equals to inverse sine x. So as you can see, the graph of the inverse function is the reflection of the graph of the original function y equals sine x about the line y equals x. Okay, so this is the graph of the inverse of the y equals sine x, which is y equals to inverse sine x. So y equals inverse sine x can be written as y equals to arcsinx. It is important to remember that negative 1 here is a superscript and indicates an inverse function. So therefore, this is not an exponent, and we cannot say that inverse sine x is the same with 1 over sine x. Okay? So once again, this is not equal. Okay, so let us go to the property of inverse function number 4. Okay, so property number 4, we have f inverse of f of x equals x. This is for all values of x in the domain of f. Also, f of f inverse of x is equal to x for all values of x in the domain of f inverse. Once again, the property of the inverse function in number 4, we have f inverse of f of x equals x. This is for all values of x in the domain of f. And on the second one, we have f of f inverse of x equals x for all values of x in the domain of f inverse. So, for example, we have inverse sine of pi over 8. So, in this particular example, using this property, or the f inverse of f of x is equal to x, this is equal to pi over x. But be careful of this. This is correct since pi over 8 is in the interval of the domain of sine function, which is the interval of the domain for the y equals to sine x. Its domain is from negative pi over 2 until positive pi over 2. And as you can see, pi over 8 is within the interval of negative pi over 2 and pi over 2. So be careful to not to overlook the domain restriction. Okay, so another example. If you have inverse sine of, let's say we have sine of pi over 3, what will be the value of this? So look at, remember the domain of the functions y equals to sine x. So the domain of that, we have y equals to sine x, its domain is from negative pi over 2 until positive pi over 2. So is pi over 3 belongs to this interval? Yes. So therefore, we can say that this is equal to pi over 3. Next. Okay, let's say we have sine of inverse sine of 1/2. So, remember the domain of this inverse function or inverse sine x. So, in y is equal to inverse of sine x, its domain is from negative 1 until positive 1. So, do you think that 1/2 belongs to this interval? Yes. So, therefore, this is equal to 1/2. Okay, another example. Inverse sine of 7 pi over 6. So, look at the domain of sine function. So, in y equals sine x, the domain is from negative pi over 2 until pi over 2. So, do you think that 7 pi over 6 belongs to this interval? Of course, it is not. So, therefore, we cannot say that this is equal to 7 pi over 6. But what are you going to do? So, at this point, we need to look for a value in the domain that corresponds to the same value of sine. So, since sine 7 pi over 6, okay, so that is equal to sine of negative pi over 3, we can substitute that sine 7 pi over 6 will be sine of negative pi over 3. But how did we say that they are equivalent? So, if we have here a unit circle, you can find out that the value of sine 7 pi over 6, here is the 7 pi over 6. Sine is the y-coordinate, that is negative 1/2. So, negative 1/2 or sine 7 pi over 6. This is also equivalent to sine of negative pi over 3. So, negative pi over 3, oh sorry, it's negative pi over 6. So, negative pi over 6 can be seen in here. So, it's negative 30 degrees. So, as you can see, the value of that, since sine refers to the y-coordinate, it's also negative 1/2. So, therefore, we need to substitute that sine of 7 pi over 6 is sine of negative pi over 6. So, from the given inverse sine of sine 7 pi over 6, this will now be equal to inverse sine of negative pi over 6. And since negative pi over 6 is within the interval of negative pi over 2 and pi over 2, the value of this is negative pi over 6 or negative 30 degrees. Okay, so once again, these are the 4 properties of inverse functions, and we were able to apply this to find the inverse of the function y equals to sine x. So that's all for today. I hope you enjoy learning about the properties of the inverse function and the y is equals to inverse of sine x. So before I end up my video, I would like to give my special thanks to Mr. Eldrin Deligan, and I hope you learned something. Goodbye!